Alright, let's see how this goes. Welcome back, guys. Had a nice week off. We're into the last 6 weeks of school, and then we got a week of exams. We're going to jump over chapter 10 for a moment. The next 2 to 3 weeks we're going to spend talking about circles. And this is really sort of an introduction chapter. So I'm sorry I'm gone today. I'm now going to be on, looks like on Mondays and Thursdays. I had to rearrange my schedule a little bit. So I apologize for doing that, for changing things up. But Mondays and Thursdays I'll be gone. So today I've got just sort of an introduction into circle vocabulary. Some of it is new, and I guarantee some of it's review. But really want you to have a good comfort talking about circles and talking using some technical words, more official words. So there's your title, Circle Vocabulary. Today is Monday the 28th. I think I have my date correct on there. You'll see some pictures up here. You got crop circles on the top left. It's probably hard to see. This is a rain puddle here with a bunch of circles that are expanding out from that location of the droplet landing. You've got, maybe hard to see what this is, a spiral staircase, and you got some roller coaster rides, which, you know, the curvature of each of these, they're not, maybe not circular, but they're related to circles. Anything with curvature we can relate to circles in some way, shape, or form. And then, of course, that's my bike. I went for a bike ride on, spring break, and I want to show you a picture of my bike. So, first question for you on your paper is just a quick definition for a circle. And a lot of you think you know what a circle is, so I want you to draw one. And I'll show you the slowest way to draw a circle. Hopefully this pops up on the screen here, little by little here. It's taking a while, huh? That's the start of a circle, and I'm intentionally drawing it slowly. This would be if I was drawing a circle dot for dot for dot for dot. Of course, a circle is, the most basic part of it is it's a collection of points. You'll see I drew a bunch of those points. You can probably see 2, 4, 6, 8 or 9 or 10 of them on your screen. There's obviously an infinite number of them. If I were to continue doing this and not take my pencil off the paper and draw a continuous set of points, that'd be the quickest way to do this. What do you think you can say about all of those points? I didn't randomly draw this. I didn't draw one over here. There's something that's the same about all these points. And hopefully you realize, it has to do with distance. There's the continuous version. All those points are equally distant from the center, or equidistant is what we use from the center. So that center point might be 10 feet away. Every one of these points are 10 feet or 10 millimeters, 10 inches away. So that's the most basic definition. Now you want to make sure you kind of restrict this to a two-dimensional plane. If you just left this definition, you'd actually be defining a sphere or a ball. All the points on the surface of a tennis ball are equidistant from the center of that. So you just say this is on a plane. This is two-dimensional. In other words, it's on one flat surface. All right, let's add in a couple words you already know to this definition. So there's a definition of a circle. I think you know what that's called. Sketch one of these on your paper. Basically just go from one point to another point. I think you know what that's called. And then sketch another one that's very similar to that. Sketch another one that looks just like this, but it goes through the center point. So it goes from one side to the other, and it goes through the center. This just goes from one point to another point on the circle. I'm certain you know what that's called, because we've even used the word a few times. And then do another one. Third one on here. So we got 3 definitions. We're going to have 3 pictures of those. You know what this is called. When a line goes, or a segment goes from the center to the edge of the circle, you know exactly what that's called. So think about those 3 definitions, those 3 words. Let's figure out where they go over here. I'm going to add some letters on here. Little d and little r. You know exactly what they stand for. They're going to go in here somewhere. And the one you may not have remembered is chord. So the chord is this one here. Think about what a chord does, and you'll be able to fill in that blank. The second word we're going to define here is diameter. That was little d up here. You know what a diameter is. And the last one, of course, would be radius. So 2 of these words you've definitely had. You've probably seen the word chord and probably used it a little bit in a previous math class. So chord is a circle whose segment, we've got one now to look at, whose blank are on the circle. Well, it's its endpoints. Start point and end point are on the edge of the circle, or right on the circle. A diameter is the exact same thing. So a diameter is a chord. A diameter, if you wrote a longer definition, you'd write this exact same thing. But we're just going to say a diameter a diameter of a circle is a chord. It's important to understand it's a type of chord. So it fits this definition, but it doesn't just go, the short distance here. It goes the furthest distance through a circle, which would be through the center of a circle. So the diameter is basically the maximum chord you could draw, the longest chord you could draw in a circle. And the last one, of course, a radius. You know the radius is half of a diameter. This is the definition for it, though. A radius starts at the center and goes to the edge, or the outside of a circle. Pretty simple. And of course, you could draw those backwards. You could start on the edge and go to the center. Doesn't really matter. Of course, you think of the guitar picture I've got here. Each of these strings going across the circular part where the noise comes from, or sound comes from, each one of these are what type of segment? The actual string through here. And hopefully remember they're called chords. Now the segment from here to here is called a chord. There's another name for it. If we consider the line that goes all the way through the circle and goes beyond it, it's called a secant, which we're going to get into in the next set of definitions. So take a minute. It's good to draw this with a ruler. And if you don't do it with a ruler, just, if you were to do this with a ruler, you'd want to make sure the ruler just barely touches the edge of a circle. There's a name for that one, and it's a word you've seen before, but you didn't know it related to circles. And then I want you to draw one that actually goes through the circle, like we did in the last one, the chord, but it continues beyond. So it's got arrows on either end. It goes from end to end, goes through the circle in two locations. This one just barely touches the circle on an edge in one location, and only one location. This bottom one is called a tangent. Like I said, you've seen the word before. You're going to see it a lot in this chapter. Make sure you learn it. Tangent intersects a circle in exactly one place. Just has one point of tangency. The second one is called a secant, which is actually another trig word. These are, if we were to define where they come from, it does relate to trig on here. This top one is called a secant. A secant intersects a circle in exactly two places. And the last one I've got for you is this point, this location where the line or tangent line just barely touches a circle. That's called a point of tangency, or a POT, point of tangency. So that location is just the one spot where it barely touches a circle. As I bring my pen just barely up to the edge, the instant I make contact, that's a point of tangency, that one little location. So there's two more words, and then sort of another aspect. You'll see these in word problems later on. You'll have to be able to draw these and model these and understand what they mean in theorems later on as well.